All right. So where did we end last time? We discussed about the how to find the maxima and minima of a function. So we focused on finding the local minimum and local maximum. So we had given the algebraic definition of local minimum and local maximum. Just the functional definition basically. That if at x equal to a, f of a is greater than or equal to f of a plus h and also greater than or equal to f of a minus h, then it is said to be maximum at x equal to a. X equal to a will be the point of maximum and f of a is the maximum value. Similarly, the function f is said to have a minimum at x equal to b if f of b is the smallest value in the neighborhood. That is, f of b is less than or equal to f of b plus h, and f of b is less than or equal to f of b minus h, or h, however small. So that was the functional definition. Then we discussed the first derivative test. The first derivative test, if a function attains a maximum or minimum, a continuous function, then at a point, not at the end points of the interval, just at, somewhere in between, then the derivative at that point will be 0. So, and that's a first derivative test. The derivative will be 0 at that point, and whether it will be maximum or minimum depends on how the first derivative changes its sign. If the first derivative changes its sign from positive to negative, so here we are seeing it's a positive. I don't know whether you're able to see the arrow. Yeah. So here the derivative is positive slope. It comes to 0 and then becomes negative. So derivative changes from positive to negative across that point. Then it is a local maximum. Now for local minimum, again the first derivative will be 0 at that point, but the derivative will change its sign from negative to positive, from negative slope to positive. That is the point of local minimum. And then there may be a point where the derivative is 0. However, the derivative does not change its sign. The derivative does not change its sign. Then that x equal to 0 is called as the point of inflection. It is neither a minimum nor maximum. Now, higher derivative test simply says that if the first derivative is equal to 0 at say a, x equal to a, then we find out the sign of the second derivative at x equal to a. If that is negative, then it is a maximum. At that point, function attains the maximum value. If the second derivative at a is positive, then the function attains the minimum at x equal to a. Why that is so? Because we know the slide was flying over. So the second derivative we know represents the curvature. If the second derivative is negative, that means it's a convex curvature or concave down. If second derivative is positive, then it's a concave up. So second derivative, if negative means it's a maximum, positive means it's a minimum at that point. Second derivative at that point. At the point of inflection, the second derivative will be 0. So higher derivative test, of course, for theory sake, it is there. We need not go to higher derivative test. Just at second derivative, we can stop. If we have any issue with the second derivative test, then we can resolve it with the first derivative test. Now, continuing further, now we will discuss how to find the global maximum and global minimum. Global maximum and global minimum on an interval, a closed interval. You can find on open interval AB also. So let y equal to f of x be a function in domain D, and let closed interval AB be within the domain D. Alright, so all points within the closed interval are within the domain of D. Then the global maximum and global minimum is basically the greatest and the least value of f of x in that interval. Within that interval, whatever value f of x takes, that the least or the greatest, that will become the greatest or the least values. Now, how to find the greatest or the least values? So first thing is find all the critical points. Find the critical points of y equal to f of x in the closed interval AB. That is, find all the points where the first derivative is 0. Of course, the points where the function is discontinuous, that also we need to identify for discontinuous functions. If they are continuous and differentiable functions, this condition is sufficient. Now, if C1, C2, C3, so on and Cn are the points at which the first derivative is 0, then observe this carefully. What will be the global maximum? See, at these points C1, C2, C3, Cn, there may be local minimum or local maximum. So, for global maximum in that closed interval, along with the function values at the critical points, we also have to consider the values of the function at the boundaries f of a and f of b. Of all of these, we have to find which is the largest value. That becomes the global maximum. And global minimum will be of all the function values at the critical points and at the boundaries. Whichever is the least, that becomes the global minimum. So let's take an example graphically. Let us take a function like this. So generally it is like this, or a polynomial can be of this form. Now this is the boundary A and B. Now if we look at the critical points where the derivative is 0 are 4 points. 4 points where the tangents are horizontal. So these points are C1, C2, C3, and C2. So here we can see, so we can observe here the local maximum occurs at C2. So f of C2 is the local maximum value, and then f of C4 is also the local maximum value. However, f of C4 is greater than f of f of C4 is greater than f of C2. This is f of C2, this value. But you can see that f of A is greater than f of C4 also. So if we consider this closed interval AB, although f of C4 is the greatest of the values at the critical points, but because of the interval under consideration, at the boundary we see that the function has largest value. Now similarly the minimum, from amongst the critical points we can see that this f of C3 is the least value. However, f of B is lying, the value is lower than f of C3. So here we can see that f of A is the greatest value, f of B is the greatest value, although the critical points there are 4 critical points. None of the critical points should get the global maximum or global minimum. So this can happen. It can so happen that within the interval, the maximum point will be, suppose the interval chosen is C1 to B. From C1 to B, which is the global maximum from the interval C1 to B. The global maximum in that case will be f of C4. Okay, because at C1 the function is small, and here this within that particular interval, this is the largest value. And similarly, if we take the interval A to C4, then the least value will be f of C3. It will not be f of B because B is 1 in the consideration. So now what to do if we have an open interval? This is a little tricky. If there's an open interval, alright, so everything else is the same. We find the critical points, and at the critical points, amongst the critical points, we find the greatest and the least value. Up to this, so we omit because A and B are not included within the interval. It's an open interval. So f of A and f of B are not a consideration. Anyway, so amongst the critical points, we find M, capital M, which is the maximum of all the function values at the critical points, and small m, which is the least of all the function values taken at the critical points. So capital M is the largest value among all of f of C1, f of C2, f of C3, so on. And small m is the least among f of C1, f of C2, f of C3, so on. Now, if when we approach the boundaries, limit extends to a plus at the left boundary of the function, and limit of the function extends to b minus at the right boundary. If both of these limits values are lesser than capital M, then The global maximum is capital. All right. If any one of them is greater than n, then the function does not possess a global maximum. Let us look at this example. All right. Here, what is m? M is maximum of f of c1, f of c2, f of c3, f of c4, and capital M. Amongst these four, the largest value is f of c. This is maximum. Now, we can observe, now A and B are not included. However, point just next to A, to the right of A, is included. Point just to the left of B is also included because it's an open interval. So what we have to study is, we have to see as x tends to a plus, what value does the function tend to? So here we find that limit x tends to a plus f of x, this value is larger than, so naturally it is tending to this value f of a, it is tending to that, and that is larger than n, f of c4. And this one is lesser, limit x tends to b minus f of x is less than m. So this part is okay. So this ensures that m is maximum. But however, this part says that there are values of the function greater than m. So which value, let us say a is 1. Now a cannot take the value 1. The interval does not include 1. Let's say b is say 8. Let us say for argument's sake. So it is 1 comma 8 open interval. So function value cannot be found at x equal to 1. It has to be found at values x greater than 1. So now, which is the greatest value of the function? All these values are greater than n. Which is the greatest value? The greatest value is at 1.01. Can you say? Or can it be 1.00001? Or will it be greater at 1.000? Can you define? No, there are infinite numbers of numbers. So you cannot pinpoint a maximum value. F of x is tending to f of a but not equal to f of a. Therefore, we say a function does not possess a global maximum. Understand? Similarly, let us consider the next case, minimum. So this is the minimum of f of c1, f of c2, f of c3, and f of c4. And the least value is f of c3. So this is m. Now, when you take the left hand limit, right hand limit at a and left hand limit at b, let us see what happens. So limit x tends to a plus f of x is very large value compared to smaller, no problem. We have to check for the least. So So still m is the least. However, this value m, this is small m, this is capital M. Now this value small m is greater than limit extends to b minus f of x. So this is the least value. So least cannot be defined again. Again, in this particular case, the least cannot be defined. So which will be the least? For x equal to 7.9, no, between 7.9 and 8, the infinite numbers. Between 7.999 and 8, the infinite numbers. Between 7.99999 and 8, the infinite numbers. So you cannot define a particular value of function which is the maximum. So that's why in such a case we say it does not possess a global minimum. However, if small m were to be lesser than both the limits, then global minimum exists. That will be it. Okay, so this was about global maximum and global minimum. And one last point to conclude, which is seldom asked in exam like page, but still it is a point to complete. It can be asked also, piecewise discontinuous and non-differentiable function. So for discontinuous functions or non-differentiable functions, the derivative test cannot be applied. That is long. So at critical points, the basic definition or the functional definition has to be applied. Not the first derivative test or the second derivative test. Neither first nor second. We have to apply the functional definition. F of a greater than or equal to a plus h greater than or equal to a minus h for maximum. And f of a less than or equal to f of a minus h and less than or equal to f of a plus h. That we need. All right. Now, before I get into making use of the problems, I want to solve 2 or 3 important problems for examples, where I explain the efficacy of first derivative test and second derivative test, which is when to be used. So consider f of x is equal to x cube minus 6x square plus 9x plus 5. Okay. First part of the question, which we'll do first, is find the points of minimum and maximum. So these are local minimum and local maximum. Find the points of minimum and maximum of this function and corresponding function values. All right. So this is something simple which we all have done, and this everyone really knows how to do it. But here, please pay attention. I'm going to do it in 2 ways. I'll use first second derivative test, which is easy in this case, and I'll do the first derivative test. Next. So using second derivative test, this is f of x. F of x is x cube minus 6x square plus 9x plus 1. Now differentiating, this implies f dash x will be 3x squared minus 6 into 12x plus 9, which will be 3 into x squared minus 4x plus, which turns out to be 3. You can see we can factorize this. 1 into 3 is 3, and sum of that is 4. So we can write this as the factors will be 1 and 3. So x minus 1 into x minus 3. So for f to be attaining a minimum or a maximum, f dash x, the first derivative must be 0. So f dash x equal to 0 by either x equal to 0 either x equal to 0 or x equal to 3. Okay. Either x equal to x equal to 1 or x equal to 3. So for f to be attaining minimum or maximum, this is so at these 2 points, x equal to 1, x equal to 3, derivative is 0. Now will it be maximum or minimum? Let us check. For that, we apply the second derivative test. Second derivative, f second derivative of it is, now we will not differentiate this part, this factorized part. It is better to differentiate this polynomial form. Okay, so you get 6x minus 12. Now second derivative is 6x minus 12. Now add x equal to 1. The second derivative will be 6 into 1 minus 12, that is minus 6. Second derivative is negative. Therefore, at x equal to 1, f attains the maximum value. Because when second derivative is negative, remember, curvature will be convex. That means this point will be the point of maximum. Now at x equal to 3, the second derivative at 3 will be 6 into 3 minus 12, that is 18 minus 12 is plus 6. It is positive. Therefore, at x equal to 3, f attains the minimum value. So x equal to 1 is the point of maximum, and x equal to 3 is the point of minimum. Here, f second derivative is negative, the second derivative is positive at this point because of the curvature. Okay. So now let us find the minimum and maximum values. So f of 1. So f of x is, let us write f of x. f of x, which is x cubed minus 6x squared plus 9x plus 5. So the local maximum value and x equal to 1 and x equal to 1 is f of 1, substitute in this, 1 cubed is 1, 6 and 1 square is 6, plus 9 into 1 plus 5. So 1 plus 5, 6, minus 6, 0, you get plus 9. This is the local maximum. Then the drop. Okay. Local minimum value at 3, f of 3 is 3 cube minus 6 into 3 square plus 9 into 3 plus 5, which is 27 minus 9, 6, 54 plus 27 plus 5. 27 plus 27, 54 minus 54 plus 5 is 5. So at 1, the value is 9, at 3, the value is 5. So this is the local minimum. The second derivative test. Now, I would wish to highlight an alternative method using the first derivative test. This is faster in many times. So f of x cube minus 6x squared plus 9x plus 5. First derivative as we found out earlier, again I'm writing 3x squared minus 12x plus 9, which is 3 into x squared minus 4x plus 3, which is equal to 3 into x minus 1 x. So this is f dash x. Now f dash x is equal to 0 and x equal to 1 and also at x equal to 3. At both these points, the function is the derivative is 0. Now, just using the first derivative test, let's draw the number line like this and let these be the points 1 and the point 3 on the number line. Okay, this is the point 1, this is the point 3 on the number line. Now, I want to find the sign of f dash x. So, I'll use the number line sign scheme. What it says, as long as the coefficients of all the factors are positive, coefficients of x in all the factors, all the linear factors, these are all linear factors, is positive, and for all the factors, the derivative, the powers are odd. If there are even powers, that factor should be omitted. But if they are for sign consideration, if they are odd powers, the sign should be considered. And if all the coefficients are positive, go to the extreme right, write a plus sign. Alternatively, put a minus sign and put a plus sign. Because the coefficient of x square is positive. Coefficient of all the products, the coefficient is positive. So when x is greater than 3, x minus 3 will be a positive factor and x minus 1 will be a positive factor. So product of two positives will be positive. So in all this region, the derivative will be positive. In between 1 and 3, x minus 1, when x lies between 1 and 3, x minus 1 will be a positive factor, but x minus 3 will be a negative factor. So product will be negative. So that's why it's negative, positive. Next here, both will be negative. So therefore you get positive. So there's a number line sign scheme. If you remember, we just draw like this, plus, minus, plus. It's very easy. Once you have practiced, it's very simple to do it. So now f dash x is pairing like this. It is not f of x, it is f dash x. So just a scheme, you don't have to draw this curve like this. Just to, so now at this particular point, f dash x at x equal to 1 is changing its sign from positive to negative. So f dash x is changing from positive to negative means at x equal to 1 in the real graph of f of x, this is at x equal to 1, your f dash is changing from positive to negative when you move across x equal to 1. That can happen only when this is the point of maximum. So we know that at f dash x is equal to 0, there has to be a maximum or minimum. So this particular point, f dash x is 0, right? And f dash x changes its sign from positive to negative. Therefore, it is a point of maximum. And this one, f dash x changes its sign across this point 3 from negative to positive. So it will be like this in the real graph of f. This is real graph of f. So across that critical point, so the derivatives are changing from negative to positive. So this is the point of minimum. Clear? So this is the first derivative test. So I didn't do anything. I didn't have to do a second derivative. I straight away found the point, which is the point of maximum and which is point of minimum. So therefore, the local minimum, local maximum at x equal to 1 is f of 1, which we found out to be 9. And local minimum at x equal to 3 is f of 3. Okay. So this is a simple algebraic equation. Now, in general, when there's an algebraic equation and it's a polynomial, it's an algebraic polynomial. Doing second derivative test is very easy and straightforward. In other cases, I'll take an example next. It will appear difficult to take second derivative. All right, we will discuss that. But there is one more component to this question, which I would now want you to look into. Find the global minimum and global maximum Find the global minimum and global maximum of a same function in the interval, let's say minus 1 comma 5. Minus 1 comma 5. It's an interval. Minus 1. So what we should do according to the previous, the discussion that we have to find the critical points and the end points of the interval and the critical points. We have to identify and choose the minimum maximum value. So we already found the critical points. So the critical points are x equal to 1 and x equal to 3. Now, for which the function values are f of 1, f of 9, and f of 3. Now, let us find f of x equal to 1. It's x cubed minus 6x squared plus 9x plus 5. We will find f of minus 1 at the boundary. At the critical points we have found, we have to find at the boundary of the interval. F of minus 1 is minus 1 whole cube, which is minus 1, minus 6 into minus 1 whole square, that will be 1, plus 9 into minus 1 plus 5. So we get minus 16 plus 5 is minus 11. Minus 9 minus 1 is minus 10, minus 16 plus 5 is minus 11. What is f of 3? F of 3 is 3 cube, sorry, not 3, f of 5. Is already a critical point. The next, the rightmost boundary. So 5 cube minus 6 into 5 square plus 9 into 5 minus 5. So we get 125 minus 25 is 115 plus 45 plus 1. We get minus 150 plus 50 is minus 100, 125 minus 100 is. So now we have to choose n smaller is minimum of function value at the boundaries and the function value at the critical points. So which is the minimum? The minimum of minus 11, 9, 5, and 20. Which is the least? Minus 11 is the global minimum. Alright. Capital M is the maximum of the same thing. It is the maximum of minus 11, 9, 5, 25. 25 is the maximum. So global minimum is minus 11, global maximum is 25. Amongst this. If the interval changes, of course, minimum maximum values change. So I'll just try to depict this. I will try to explain certain things about graphs. Pay attention. Yeah, this is y equal to x cube minus 6x square minus 6x square plus 9x plus 1. See the function, how it looks. Generally, it's a cubic function. Remember, when the cubic function has positive coefficient of x cubed, the highest degree, the positive coefficient, the function tends to go as we go to the right, the function goes to plus infinity, as we go to the left, function goes to minus. And this is the way there will be two. Generally, there will be two stationary points, points where the derivative is 0. Now, suppose I change I'm just trying to change and show. That if it's a quadratic, if it's a close, right? So y equal to x cubed minus 6x plus 9x. Now I'm just introducing the minus sign and see how it changes. Same thing with the minus sign. I'm writing this graph and this graph now. And you do a minus sign, again you get two critical values, but the curve goes from left side it goes to positive infinity, right side minus infinity. If I change this way, it is like this. Okay. So if you have some idea of these graphs, it will be very, very useful. Now I'll show you quadratic graphs. Now, quadratic graph, the positive coefficient of x squared. Gray color. So let's say positive coefficient of x squared. This is the graph. Positive coefficient of x square, it will be parabola opening upwards, and this is, the single stationary point. It will happen. If the same thing I have a negative sign, it will be a parabola opening downwards. So these things, just seeing the equation, mentally we can tell whether it will be minimum, maximum, and so on. So many times without, I will do some exercise problems with you where this understanding will help you, straight away get to the solution without even actually solving the problem. So now let us see this value. This is 9. Yeah. If I click this point, this point, see, it is 1, 9. At x equal to 1, the function value is 9. For this graph, x cube minus 6x squared plus 9x plus 5. And for x equal to 3, you get a minimum value which is 5. But at x equal to minus 1, at x equal to minus 1, the value was minus 11. Here, when x is equal to minus 1, the value is minus 11. And for x equal to 5, this is 4, this is 5. For x equal to 5, for x equal to 5, what is the value we got? 25.
25, sir.
For x equal to 5, we got 25. So that's how the graph looks like. The graphical understanding of cubic functions and quadratic functions is useful. And if it's a biquadratic, suppose I add another term of x power 4, then I can show you that also. I'm just suppressing all these points. Now I'm adding x power 4 term. See here, g of which I'm adding x power 4. Power 4 term 1, 3. I will add 0, 1, 4. So here we see there is 2 points of maximum minimum here. One minimum, one maximum, and at the bottom here there is another. Of course, if I change this to positive, I'm just playing with some of the roots, products of the roots and polynomials. That's all. So here we see when x is equal to x power 4, we get a graph more like a distorted W. And x power 4 is a negative coefficient, then it will reverse. Okay, that's why if you see when I did this graph, I said this is a polynomial of degree 5. Why? Because it will have 4 stationary points. Because polynomial of degree 5 will have derivative of the fourth degree, and it can maximum have 4 roots. So these are the 4 roots: 1, 2, 3, 4. So this is a polynomial of degree 5. With, I can also predict that this has a negative coefficient of x power 5, because this is going to plus on the negative side and minus on the positive. So these understandings help us to solve the problem very, very efficiently. That's why I'm emphasizing this. Otherwise, just blindly mathematical calculation or second derivative test you can do. To make it more efficient, sometimes we can do first derivative test. This is global maximum. Next, I'll give another question, which will be of importance. There's a second example. Now, consider f of x is equal to x minus root of 4 minus x squared. Okay. Now, find the local minimum and maximum value of this function. So now this is not a straightforward polynomial, it is an irrational algebraic equation. So f of x is this, x under root of 4 minus x squared. So differentiating, when we differentiate, we have to differentiate derivative of the first function keeping second constant. The derivative of x is 1 plus keeping the first function as constant, differentiating the second. It's 1 by 2 under root 4 minus x squared into derivative of the expression within the root by chain rule minus 2x. Okay, what happens? 2 cancel. Then we bring it to the common denominator, under root of 4 minus x squared multiplied by itself. Will give 4 minus x squared, and this is x into minus x, which is minus x squared by under root of 4. We get 4 minus 2x squared by 4 minus x squared under. This is the derivative. Now, the common sense tells us that going for the second derivative will complicate the issue. We can get it, but it will take more time. But anyway, if first derivative has to be equated to 0, we get 4 minus 2x squared, which will give us x as plus or minus under root 2. Now, I will go by the first derivative test only. In this particular problem, if it was a simple plain polynomial, then second derivative test is easier. In this particular case, first derivative test is easier. So now f dash of x, I will write as take 2 common, or say minus 2 common. I get x squared minus 2 by under root of 4 minus x. And this is x plus under root 2 into x minus under root 2. Now, in the domain of discussion, when x is around plus or either plus root 2 or minus root 2, the denominator is under root 2. Okay, we can very clearly see that. So denominator exists, so we don't have a problem. So, and it is positive. So sign, it does not contribute in the sign change. this remains the same value. The factors that change sign across the critical points x equal to minus root 2 and x equal to plus root 2 are these two factors. So now let us plot the number line. We plot the number line. In the number line, mark minus under root 2 and mark plus under root 2. Okay, just put the factors, don't put 0 or anything. Just mark only those values which are the roots of f dash equal to 0. Now, when I go to the extreme right, it should be positive, the product, because coefficients of x square, x and x are positive here. However, it has a negative sign. So although these two factors will both be positive, multiplied with the negative sign, f dash value will be negative. Conversely, now for the next interval, the product will be negative, but it is multiplied with the negative sign, it becomes positive. And in this interval, the product is positive because both are negative values, and multiplied by a negative sign. So negative into negative is positive, multiplied by negative will be negative. So you don't have to worry on it. In all linear factors, when you have to the extreme right, you just put positive if the overall coefficient is positive. If overall coefficient is negative, extreme right is negative, and the next interval positive, next interval negative. So of course, because this is f dash, this is f dash x. Now by first derivative test, please tell me what will this value be? Which point? This at this point it's an extremum, either minimum or maximum. Now tell me what is this?
The point of minimum.
Good. It is the point of minimum because f dash x is changing sign from negative to positive. The slope is negative to positive. So this is the point of minimum. And this is the point of maximum because f dash is changing its sign from positive to negative. So first derivative test helps us in this problem. It will save time. We can go for the second derivative test. We will have to apply by u by v rule of differentiation, and you can try and you should get it. If you want, I can still do it, but I leave it here. There is an exercise problem, practice problem on this time that I have given you. You can look into that. Exactly this morning, just a number change. So we found out the point of minimum and point of maximum simply by the first derivative test. So the minimum value is at x equal to minus 2, and the minimum value is at f of minus 2 is x into under root of 4 minus x squared. So x is minus 2 into under root of 4 minus under root 2 the whole square. Minus 2 into 4 minus 2. So minus 2. The maximum value is at x equal to plus under root and f of under root 2 minus 4 minus square. This is the maximum. Clear? So first case was a simple polynomial, the second case was a irrational function. Third problem, it's a trigonometry. Consider f of x e power sin x upon e power cos x. Find the maximum and minimum values of x. Now, this is exponential function. F of x can be written as e power sin x minus cos x. Now, we know that an exponential function is an increasing function. So, this is the graph of the exponential function. Yeah. The exponential function is an increasing function. So, as x increases, e power x increases. So, here instead of x, we have another composite function sin x minus cos x. So, we can treat this as e power g of x. And since e is an increasing function, so we just have to find the greatest value of g and the least value of g. Okay, as e power x is an increasing function, strictly increasing. Right? Now, e power g of x is maximum when g of x is maximum. And it is minimum when g of x is minimum. Okay. So now let us look at this. Here, g of x is sin x minus cos x. So how should we do? Anybody can volunteer? How should we do? I have to find. So my problem now lies in finding the minimum and maximum values of sin x minus cos x.
Sir, converting sin x minus cos x as under root times sine of x plus pi by 4.
Again, please repeat. There was noise.
Uh, Converting sin x minus cos x as under root 2 times sine of x plus pi by 4.
Just hold on. Huh? I'm very sorry. Are you hearing my voice clearly?
Yes, sir.
Actually, my microphone setting was a different. Whole class recording went off. I'm just realizing the microphone setting. Is my voice better now?
Yes, sir.
Someone should have told me voice is not clear in the beginning. See, there is microphone. There are two microphones. One is an external and then other is internal. The whole class went into this without recognizing. When you are speaking, I realized that there is some problem because I am getting a internal feedback of whether mic is working or not, external mic, but I don't know how it is getting delivered to you. So this is the sound quality. If you have an issue with this sound quality, please immediately let me know that sound is not clear. because with all the distractions and the noise around, you will not be able to understand. Yeah, okay, go ahead.
Yes, so sin x minus cos x, I multiplied and divided by under root 2. And then I used,
Yeah, that is good. See, we can differentiate this. We can differentiate this as it is, but that will complicate the issue. Meaning, not complicate, you can still do it. It's not a problem, but better is multiply and divide by under root 2. And then this becomes sine of x minus pi by 4. This is sine A cos 45 minus cos A sine 45. So sine x cos 45 minus cos x sine 45. That is sine of x minus 45 or x minus pi by 4. So if this is g, if I have to differentiate, under root 2 remains constant. Derivative of sine is cos. This makes it easy. So this is the derivative. Now if g dash x equal to 0, it means cos of x minus pi by 4 is equal to 0, which implies x minus pi by 4 is, minus pi by 2 plus pi by 2 minus 3 pi by 2 or plus 3 pi by 2, so on. So odd multiples of pi by 2. Okay. So which means that x will be add pi by 4 to it, to all of these. You will get minus pi by 4 plus pi by 2 plus pi by 4 is 3 pi by 4. Then 3 pi by 2 plus pi by 4 is 6 plus 7 pi by 4 and 11 pi by 4, so on. All right. Now, alternatively, now if now let us look at the second derivative. It will be under root 2. Derivative of cos is minus sine of x minus pi by 4. So what we get now, let us check at minus pi by 4. We get minus root 2 sine of minus pi by 4 minus pi by 4, that is minus pi by 2. Sine of minus pi by 2 is minus sine pi by 2, which is minus 1, 2, greater than 0. So therefore x equal to minus pi by 4 is the point of, it's the point of minimum. It is the point of minimum. Okay, because the second derivative is positive. Now these are problems with the net connection. All right. Now second derivative at 3 pi by 4 is minus root 2 sine 3 pi by 4 minus pi by 4, that gives us pi by 2, and sine pi by 2 is 1. So minus root 2. Therefore, x equal to 3 pi by 4 is the point of maximum. Okay. And 7 pi by 4 is nothing but 2 pi minus pi by 4. So that is 7 pi by 4. And 11 pi by 4 is 2 pi plus 3 pi by 4 is 11 pi by 4. So these are like in the intervals of 2 pi, and this function is periodic. All right. This function here is periodic with period 2 pi. So therefore, this will be a periodic expression. So minimum and maximum keeps happening here. So if you find just g of minus pi by 4, it is root 2 under root 2 into sine of x minus pi by 4, that is minus pi by 4 minus pi by 4. It is minus root 2 is the answer. And g of 3 pi by 4 is root 2 into sine of 3 pi by 4 minus pi by 4. 2 into 1, root 2 into 1, so it is root 2. This is minimum and this is maximum. Let's look at the curve, how it looks. Okay, I'm giving an input here, sine x minus cos x. It just looks like a normal function. Only thing, you see the maximum and minimum values are not, you can put y equal to 1. So maximum and minimum are crossing, the value 1. And minimum will cross the value minus 1. You see here? Now, instead of 1, I make it square root 2. See here? So the maximum value is square root 2 and the minimum value is square root minus square root 2. So we get this. This is the maximum and this is the minimum. All right. And it is a sine function. It is just that the 0 point changes. The 0 of the curve, the whole sine curve is shifted to the right and minus root 2 and root 2. So this is a periodic function. So the minimum value of g is minus root 2 and the maximum value is plus root 2. So the answer we get of what is the minimum and maximum value of f. So minimum value of is f of minus pi by 4, which is e power minus root 2, and maximum of f okay. So this is the minimum and maximum. All right. Okay, now let's open class time. All of you open class time. I requested you all to join a classroom because each time I can just call you through a classroom. I don't know how many of you join. 3 students have joined. I request everybody else to only 2 students. This is, of course, my administrator. So others also just join with this particular class link that I have given. I have sent in the WhatsApp group. Open class time and join. Not now. Right now, we will directly do this session. I will start the session. I have questions on application of derivatives. So I start a new session. Please open class time the way you usually do. And deactivating all the questions. See, this is D, capital D, capital W, 55M. This is the code. So please enter that code. So when you enter the class time like this, enter the code DWW 55M. Okay, if you have a student account, that means you log in with your Gmail and keep an account, and I invite you to the class. With that account, if you join the class, you can straight away log in, and all the things that you have done, the assignments that you have taken or quizzes that you have taken, you will have a record of it. Okay, that is why I'm saying. How many did you do correct and wrong? You can verify it later. With this, you don't have that access unless you join with the okay, let me see how many of you have joined. Good. Pretty much everybody. One more participant. One more participant is missing. So please join. I'll start the question. The first question I'm starting. So the question is, there's a question. A non-zero polynomial f of x of degree 3 has roots x equal to 1, x equal to 2, x equal to 3. Which one of the following must be true? Now, this is not a question directly on maxima and minima. That's the hint. You look at this question carefully. But it has to do something from what we have done in this class. So I will shrink this. This is the question. These are the answers. I'll set the timer already given. Start. Good. Another minute. All right. All right. So let's see the responses and good time. So correct answer is, 8 students have given correct. Others have given um, wrong answers in different categories. So now just look at this. I will solve this. Just a second. So this is a problem solving session. Yeah. So as I explained earlier, that see f is of degree 3 and has roots at x equal to 1, x equal to 2, x equal to 3. So what does that mean? It's not that the derivative has roots, the function has roots. The function has roots at x equal to 1, at x equal to 2, and x equal to 3. Now nothing is said about the coefficient of x, highest degree term. Doesn't matter. So there are two possibilities. If coefficient of x cube is positive, we will get a curve like this. A cubic polynomial will have a curve like this. Now these are points 1, 2, and 3. Now f of 4 will be a point, will have value somewhere here, or maybe here. So this is the value of f of 4, it is positive, and f of 0 will be negative. This will be the curve. See, I said just by seeing the curves you can tell. So f of 0 and f of 4 will be of opposite signs. Why? The logic here, another logic by not Rolle's theorem, the intermediate value theorem. Rolle's theorem, in fact. See, f of 1 and f of 2 are, function is continuous, it's a polynomial, continuous and differentiable, and f of 1 equal to f of 2. So by Rolle's theorem, there should be some intermediate value where the derivative is 0. So there will be one maximum attained, maximum or minimum attained. Then f of 2 is equal to 0, f of 3 is also equal to 0. So in between these two, again, there should be one extremum. All right. Now, function is continuous, so its derivative should also be continuous. So therefore, function, say, increases, decreases, and then decreases, increases. So, and these are the three roots. So in between, if this is the root, then function value has to change its sign. So this is the way it will be, function polynomial. Now, if the coefficient of x cube is negative, then the functional curve will be like this. In that case, f of 4 will be negative, and f of 0 will be positive. Again, they will be of opposite signs. Again, they'll be of opposite signs, and therefore the product will be negative. So this is the correct answer. Okay. So this is the correct answer. Now so I hope you understood how we approach this problem. So next, we'll move on to the next question. Okay. This is the question. This is an easy question. So let's start. I'll give you 2 minutes. Please start. It's an easy question. F of x is equal to x into e power minus x. The maximum value of the function in the interval 0 to infinity is. Good. Good. All correct answers so far. Good. Others, please try. Very good. Another 10 seconds. I'll give. Okay. One person still to answer. Please answer. Okay, I'll tell how to do it. It is like most of you have done it. I may not have to do this problem. It was very simple. And what I'm doing now, I'm giving you the previous year's GATE questions straight away. The examples that I taught you, 2 of them are not GATE questions. They are basics to build, but all these are GATE questions. What I'm teaching now. So f of x is x into e power minus x. So first derivative is first function differentiate, keeping the second constant, plus keep first constant and differentiate the next. So don't miss the minus sign. So e power minus x to 1 minus x is equal to 0, which means derivative is 0 will imply that x equal to 1. Now first derivative, minimum or maximum, it's only one point. There is no other point. And you can see when x is greater than 1, the derivative will be negative. When x is less than 1, it is positive. So from positive to negative. So this will be the point of maximum. 1 is the point of maximum. So f of 1 is the maximum value, 1 into e power minus 1. So this is the answer. Okay. Next question. So please solve. For t, positive value of t and equal to 0, what does maximum for this occur? E power minus t minus 2 e power minus 2t. Just a minute, I'll give for this question. 1 minute more. Good. Gone. All right. So those of you who are not able to solve this, then there is some problem of understanding of log functions and exponential functions. That would be the reason. Otherwise, it's very simple. There is nothing. Concept is same. So you just have to brush up those concepts. So just a second. All right. Okay. So this is the question. F of t is e power minus t minus 2 e power minus 2t. Derivative will be e power minus t into minus 1. Then minus 2 times e power minus 2t into minus 2. So we get minus e power minus t plus 4 times e power minus 2t. This should be equal to 0. For this to be equal to 0, okay, take this to the other side. We get e power minus t is equal to 4 e power minus 2t. Bringing this to this side, e power 2t into e power minus t equal to 4. We get e power t equal to 4. So we get t is log 4 to the base e. So log 4 to the base e. So that is the only point. There is no other point where the derivative is 0. So this is the answer straight away. Okay, so All right, next I'll open out 3 questions. Let us see how many of you do 3 or 4 questions. Let's see how many of you will solve in 10 minutes. Okay, all questions I'm opening. All right, I have given 12 minutes and 2 students have made the full attempt. Okay, good. Others have been slow. So, okay, what I'll do, I'll discuss the solutions of this tomorrow. Okay, if you want, I'll keep this test open for a while. I'll close the class now, but you can attempt. You attempt all the questions. And tomorrow I'll discuss the solutions. Tomorrow in the first half. And tomorrow, first half, it may just take, 30 to 45 minutes. After that, I would like to start integral calculus. All right, tomorrow. And some of you might be having exams after the opening of the lockdown. So you just let me know if there are majority who have exams scheduled, then I can try to reschedule the class. Otherwise, like if there are few, then I will continue and others can see the recording.